Hi everyone, welcome to today's webinar, Mastering Color Consistency, Enhancing Quality Control with X-Rite Benchtop Solutions. Presenting today is Tim Mao, the Global Customer Solutions Manager at X-Rite. I'm Robert Grotans, the Global Experience Manager, and I'll be moderating today's webinar. I just want to go over a couple of things before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions during today's presentation, please feel free to use the questions function on the GoToWebinar panel, and we will have some time at the very end of this webinar to answer your questions. Finally, this webinar will be recorded, and we will follow up with an email at the end of this webinar with a link to the recording so that you can watch this webinar again. So with that, I will turn it over to Tim to get things started.
Thank you, Robert. Good morning, good afternoon, and good evening. Welcome, and I'm here, as Robert said, my name is Tim. I'm here to talk to you about benchtops, enhancing your quality control experience with X-Rite's benchtop spectrophotometers. So let's go ahead and dive into our material for the day. First, just a little bit about X-Rite, in case you aren't familiar with us. X-Rite Pantone. Pantone is part of of us as well, right? We are the leader in color science and technology. We make many different kinds of instruments, devices, and software packages, solutions that include education and training and support in all kinds of workflows around color throughout the world. The things that we help you do with all of those solutions are helping you improve the time to market, help you align your physical color with digital color as the world becomes more digital, to try and move things along faster, right? We have the ability to do that. We're here to help you improve quality and compliance, right? That you may have to meet around color, and also to help you optimize, your dollars that you're spending by reducing rework, by eliminating, the waste that can come from producing product that does not meet color specifications. So it's a bit about X-Rite. We've got lots of good material on our focus for the day, so let's dive in. Real briefly, here's our agenda. We're first going to talk about the importance of selecting the right instrument. If you're going to measure something, what instrument do I select? Well, what you're measuring matters in selecting that, and then we're going to talk about this thing called inter-instrument agreement, or IIA, as we often abbreviate it, and we'll talk about maintaining that as well. Following that, we will talk about tolerancing, which is an art. There's a reason we call it the art of tolerancing. And it's about how to choose what's the right kind of tolerance to use. There's lots of them out there, and the right ways to go and set that up. And then ultimately, how do those first two main bullets impact quality control, right? What contributes to your color variation? We're going to talk about that and all of the contributors, and how can I make my tolerance not just be a thorn in my side that tells me when things are bad, but how can it help me actually reduce waste? And so through all of this, we'll be giving you some tips and tricks and guidance on ways to make all of these tools really work for you. Our goal in life is to make your life better. And if you've got to manage color, sometimes your life is good and sometimes it's not around your color production. So we're here to help you with that. All right, so selecting the right instrument. It starts with, what are you measuring? So since we're talking about benchtop spectrophotometers here, the first question might be, do you need to measure reflectance or transmittance? Reflectance being light shining on the sample and how it reflects. So I'm going to put my sample up here at the front of the instrument and measure how light bounces off of that sample or reflects, right? But maybe you're measuring something that you need to do a transmission measurement, right? depending on what it is you're measuring, right, will have an influence on what kind of instrument you need. Because we have benchtops that do reflectance only, and we have benchtops that do both reflectance and transmittance. So that's an input that's part of your decision. Size of the measurement area, right? The sample that you've got, it's always best as a general rule of thumb to measure as large an area as possible, because no sample you measure will be completely homogeneous. The larger the area you measure, the better, right? To average that together, to incorporate any minor variations. But so yes, great, measure it with a 25 millimeter sample, except what if my sample is only 8 millimeters in diameter? Well, that won't work because it'll fall inside the device. So, you know, this instrument has by default these these benchtop instruments have these 5 different aperture plates down to 3.5 millimeter in diameter. You know, so you can switch, because sometimes you might be measuring samples that you can use a larger area, sometimes you need to go smaller. But you need to consider that when you're selecting an instrument. The physical type of sample, I just got some examples here of things that you can add on, essentially. If you're measuring a liquid, for example, right? If you want to measure it with reflectance, you can see there's a small cuvette in this holder on the front of the instrument. We also have a cuvette you can do if you need to measure the transmission of a liquid. Maybe you're making plastic preforms, right? So we've got a special holder for this translucent preform. Maybe this is going to become a 2-liter soda bottle. That would fit in the transmission chamber and allow you to measure the light passing through it. This doesn't have a sample on it right now, this little circular donut kind of looking thing, right? That's made to actually hold like a terry cloth, right? So you would actually fold the terry cloth around there, and there's a strap that would hold it in place, allow you to measure a textile sample that's got some significant texture to it. And by putting it on a special holder that keeps it held tight and in the same orientation all the time, contributes to that. This is just a snippet of some of the options. There's lots and lots of other specifics that we can get into around specific examples, but you know, what is it that you're measuring physically? And then what about things like UV control and varying surfaces? You know, if you're measuring something that's optically brightened with an OBA, right? You may need to UV calibrate. It's kind of hard to see, but there's lights here on the screen of the device. This one indicates it's actually got the 460 nanometer UV filter in place. That might be in place to block UV. We might need to calibrate that. And varying surfaces. Do I need specular included or specular excluded, or do I want to measure both? You know, all those things are part of helping us decide what's the right kind of instrument, or the right model perhaps of instrument that you need in order to take measurements. So once we fit an instrument and say, yeah, okay, let's say we've made the determination we need a benchtop device. we understand what those limitations are. So then I need to think about this, about inter-instrument agreement. So first of all, what is it? Well, it's a method that's used not just by X-Rite, but of every instrument manufacturer, really, of quantifying how closely a brand new device that we produce measures relative to the centroid device for that same model. So if you're going to buy a model 7800 from X-Rite, we have a centroid 7800. Every instrument we make needs to try and match that. And this might be the centroid in the center with the green arrows pointing for, okay, we've made these instruments and they're all within some tolerance. Now, if I had an instrument that was out here in right field or out here in left field, if you will, right, they're too far out, they wouldn't pass that inter-instrument agreement. So it's understanding how big is the cloud, if you will, of devices that are the same model. Okay, so it's a means of reporting that. And each model has its own inter-instrument agreement specification. Now I'm going to give you some examples of that in just a minute. So, and then every X-Rite device, every device that X-Rite produces must meet its inter-instrument agreement specification. If it doesn't, we have to go back and fix it in production until it does. So we produce instruments that are always meeting that specified inter-instrument agreement. Okay, so if I'm choosing the right instrument, okay, first I've already made those reflectance transmittance kind of decisions about which instrument is right. Then I got to start thinking about this. So look at these black crosshairs, and let's assume right dead center, that's the centroid. That's the master device, if you will, is another way to call a centroid. So if I bought a CI 7600 instrument, as an example, its inter-instrument spec is 0.15 delta E. So let's assume that this orange circle represents is 0.15 away from the center point, the outside edge. What that means is all of the 7600 instruments produced fall inside that circle. Okay, if I want to buy a 7800, now I have an inter-instrument agreement of 0.08 delta E. So it's roughly half the size. It's a tighter circle. And then I can go all the way to the 7860, which is the tightest inter-instrument agreement device produced, and it's 0.06. Now, of course, typically as you get tighter inter-instrument agreement, you know, the price of the instrument increases because it's a more precise, if you will, device. So, you know, you've got additional models. These are the models I listed are all reflectance transmission. For the first two, there are also reflectance only versions of that. But ultimately, picking which one of these works for you has something to do with what's your tolerance. So what if I had a tolerance of 0.5 delta E for my product? That's how big that gray circle is relative to the others. So if that anything inside that gray circle, which of course runs off the screen, passes, can I live with an instrument? So if I had two instruments, 7600s, right? They could be 0.15 DE away from each other, right? Am I willing to give up that much of my tolerance to the instrument? Or if I have that tight of a tolerance, maybe I need to consider buying an instrument with a tighter inter-instrument agreement. We'll talk more about that error that can come from the instrument. It's part of the error stack we'll talk about in just a minute. So it's something to think about, right? What am I going to use? What instrument do I pick is not only about what does it measure, but I also have to consider this inter-instrument agreement and the precision level, if you will, of that device for relative to what is a pass-fail tolerance for me. Okay, so that's inter-instrument agreement when you buy a brand new instrument, but you also have to maintain that. And this is a really critical part for you as a user, whether you are in a workflow where you're measuring and you've got 20 other plants across the globe that are also measuring with the same instrument and all that, or whether it's just you got one instrument, you're never going to compare to anybody else. I'm going to talk about why maintaining inter-instrument agreement matters for everybody. So some of the ways that we do it is, of course, daily. Anybody who's used an instrument, you know you have to do this white and black calibration, right? Where you put the white plaque up there, the instrument measures that. You put this light trap, or what we call black calibration, up there, it measures that. It uses those to calibrate the device. Okay, after you've done that, device is ready to be used and take measurements. That's forced on you whether you want to do it or not. The instrument won't measure if it's not calibrated. The second piece here is really key and a big part of maintaining your inter-instrument agreement. Okay, it's something called Net Profiler. It's a piece of software that corrects your instrument to correlate back to the centroid, because your instrument in your environment, right, as time goes on, right, you're in a different temperature, humidity environment. It might be getting dusty, dirty. Its components are going to age, right? Now, the first year, you might not notice any drift whatsoever, but if you have an instrument for 5 or 6 years, right, things are going to slowly move, drift, and so forth. So what Net Profiler does in this software, you can see listed here, this is a certificate that comes from Net Profiler. We have another webinar we've done in the past on Net Profiler. You can go access on our website if you want more information specifically about Net Profiler, but we're going to measure 8 tiles, and those tiles that you would get with this software have values that are tied to our Centroid device. So you're going to measure with your instrument, it's going to see what it is unprofiled, and then it's going to mathematically correct it to make it closer to the Centroid. In other words, if you think back to the circles, if your instrument drifted out of the circles because of the environment or something else, Net Profiler brings it back inside that circle. That's important, again, if you've got a fleet of instruments across a fleet of locations, but it also matters if you just have one instrument, because if I measure my standard today, and in 2 years I'm going to measure a sample against that standard, I'm expecting the instrument is still measuring the same way. But if I'm not properly maintaining that instrument and it's been drifting over time, and I'm calibrating, but I'm not doing Net Profiler or annual certification, as we'll talk about in a second, I'm going to drift further and further away, and I'll be, some of my difference that's being reported between my standard and my sample now might be due to the instrument. So this is a way to ensure consistency in your measurements. And here's just a quick snapshot of what it looks like when you take an instrument in the red. That's what it looks like if it's not been profiled. That might be how far out it drifted. And the green shows what the mathematical profiling does, brings it back in, right? Both specular included and specular excluded. So it's a way to make sure your instrument's maintaining its ability to measure inside that cloud of inter-instrument agreement performance. And then finally, we've got annual certification, right? Which is X-Rite certification that your device is performing within its inter-instrument agreement. So that's your device coming back to X-Rite, or sometimes we do, in some locations, we can do field service and do it at your location. Validate that your instrument natively is measuring correctly. If not, right, we can correct that, cleaning, or in some cases it might be a repair that's necessary. And we can even do things like ISO 17025, or called A2LA, kind of certification of your device on an annual basis. Those 3 things, the daily, the monthly, and the annual together, will make sure that instrument's measuring the same, it's accurate, it's consistent, which is really important because you're going to rely on that thing to be giving you a precise answer all the time. Okay, let's talk then a bit about tolerancing. So first, we got to think about tolerancing methods, and there's a few ways to do it. One of them is to do it visually only, right? And there are people who do that, but we're here talking about measuring with benchtop instruments, and so we're gonna move on and assume that we're taking measurements. Well, there's pretty much 3 basic kinds of ways that people tolerance color, right? With colorimetric data, as we would call it. And the oldest one around is called delta LAB, which, if you were plotting it in software, you're going to get this square kind of a tolerance. 75%, what that 75% represents is how often that tolerance and your visual assessment will agree with each other. In other words, roughly 1 out of every 4 samples, the tolerance would say pass and you would say fail, or vice versa. So it's not really great. Now we can go to LCH, okay, which is a bit of an advancement on LAB, and get roughly to 85% agreement between the eye, visual, and the numbers. But ultimately, where almost everyone has landed at this point, right, is elliptical tolerancing. Whether that's delta ECMC, which tends to be predominant in the textile industry, delta E94 or delta E2000, all 3 of those, they have some minor variations in them, but they're all elliptical, tolerances, and depending on the tolerance and the materials you're measuring, get anywhere from 95 to 98% agreement between a measurement and the human eye. Now you're starting to get to a place where you can trust it. Had this conversation many times where people ask, why can't we get to 100%? Well, we can build a tolerance that agrees 100%, but it's going to be 100% to one person's vision and not another. All you have to do is think about what happens if I have multiple people looking at something. They don't always have the same opinion about whether it's good or it's bad. So, 98% is pretty high and pretty good. Probably not going to advance a lot further than that. So once we pick the tolerance type, then we've got to talk about creating or adjusting your tolerance. And so some guidelines for that. Number one, build the tolerance on real samples. I get it. Sometimes you're given a tolerance and customer says, this is what, my tolerance is this, and you have to meet that. Okay. But there's often times where you have some control there. So to start with, it's building it on real samples. Some are good, some that are good, and some that are bad. And by good and bad, what I'm talking about is some that would be visually accepted, some that would be visually rejected. Okay, if you can get those and then measure them, you can build a tolerance. And you want to base the good, bad samples on visual assessment, or even better, customer approval. If you can have your customer can say, yep, those are good, nope, that's bad. Maybe you have your customer's internal, maybe it's external. But again, getting your hands on good versus bad is really the thing. And then you measure them and evaluate the data to determine the limits. And you can do something like this, right? So this is this would be, I've measured some samples in, the green dots pass. I set up a default tolerance, the green dots pass, the red dots fail. And maybe I look at this and I go, well, that red dot right there, that particular sample actually looks good. And visually, we want to accept it. Well, then I can adjust this tolerance. I could make it get slightly larger so that that red dot suddenly starts to fall inside and turns green. That's how I'm going to adjust a tolerance and do this work based on real world, right? And get a tolerance that works and agrees. Because the last thing you want is a tolerance, yep, pass, 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 and the customer goes fail, fail, fail when he gets them. Or you look at them, right? So we need to get those things matched up. It's a little work, yes, but typically it's done you do it on a few colors, you'll find a tolerance that probably then works for most of the things you produce. Okay. Now, I've got a tolerance built, I've got the right instrument made, I'm doing QC, but what things get in the way? Well, there's a whole lot of variables that can get in the way. Production variables, obviously, when you're producing things, you don't produce them 100% the same way every single time. The raw material has variables in it. It can change. The environment can change. Anybody ever notice your production in the summer is different than your production in the winter? If you're in a northern climate, for example, where there's lots of variation, yes, that can have an impact on what happens. There are operator variables from one person to another. Instrument variables, that's inter-instrument agreement, right? And more. And what all those things do is they create what we call an error stack that can look like that. So if my tolerance is delta E of 1, okay, this sample that had this particular error stack failed. Well, which things contributed to that error? And you want to be able to control them. And when we talked about inter-instrument agreement, we want to make the instrument one as little as we can, okay? We're going to do training and SOPs and stuff to try and reduce our operator variables as much as we can. We're going to QC maybe our raw materials coming in to try and reduce that variable as much as we can. Environmental variables, we can do that through, HVAC might be part of what needs to be done to help control that. Because ultimately, you'd like to reduce all of these variables as much as possible so that the one thing that you have to do is the actual production of the product, right? You know you're going to have variables there. You'd like to save as much of your tolerance for that as you possibly can. But it's knowing what those various variables are and how they contribute, right, to whether that sample ultimately stacks up to a pass or a fail. That is huge in you being able to manage color. And there are ways to validate and test these different things. Like I mentioned, raw material variables, right? Are you actually QCing all this stuff coming in? Or maybe you're getting certificates of analysis that your suppliers have QC'd this, and you at least have that information coming in. Okay? Lots of things here to consider and think about. So how then can I make my tolerance actionable? How can it help me? Well, you're going to make it actionable by doing this. So keep in mind, the difference between good color and bad color is not a knife edge. And by that, what I mean is if your tolerance is 1.0, a sample that's 0.99 is not great, and a sample that's 1.01 is not horrible. Those two samples next to each other, no one could tell the difference between them. They're only 0.02 apart. So my point is, yes, you have a pass-fail tolerance, but you kind of want to know when you're getting close to that. And so what you can do, we have this ability in our software, is to set your tolerance to alert you when your color is drifting toward failure. And what that looks like is this. So if this is my elliptical tolerance, anything inside this outer ellipsoid would pass, okay? But I've set this particular tolerance, I think is set with a 10% or a 15% warning level. And so literally the samples in the software are going to be labeled pass if they're inside the green part. They're going to be labeled fail if they're out here, and they're going to be called margin if they fall in this yellow area. Why is that important? Well, if I've got enough margin set, I can tell my operators, you know what? If you get green things, the green pass is showing up on that sample, just keep on going. Don't change. You don't need to necessarily change anything. You can just keep cranking production. You're good. But when things start to fall into this yellow area, right, and it's in the margin, that's your alert that you need to do something, because let's say this was a trend, these dots here, right? When I got here, I needed to start paying attention to stop myself from producing things that are way out here. So that yellow margin or warning level can let you know, hey, you're starting to get to the point where you need to make some changes or you're going to have bad color. And then, while most of the world tolerances with a delta E, an elliptical delta E tolerance, which is one number, you got to use the color space delta values for what to fix. For example, right? Here I've got a bunch of samples, and you can see some of them have this yellow, right? So they're in the warning, okay? Well, it's in the margin, yeah, because my tolerance is 1 and that sample's at 0.99. Why? Well, okay, look, it's way on the dark side. It's 2.45 units darker than the standard. So if I know, and the sample just next to it is at 0.83 CMC, it's also in the margin, it's 1.37. So I'm drifting darker if this happened to be in the order that they were happening. So I need to know that, right? And an experienced operator, of course, you will know and have some idea of what things in production cause the color to shift this way or that way. You can make some movement, or even sometimes it means stop production because I'm so close to failing. I don't want to. I need to stop this thing and correct it before I continue producing more product. Maybe I've got to go adjust a batch of paint that's being applied to something, as an example. So you want to use those values to help you figure out what to fix. But the key is really getting this tolerance with the yellow, red, green, the stop lights going on. Green lights, you're good. Yellow, unlike when you're driving, does not mean go faster here. It means slow down and pay attention because you're about to hit a red light. So we've walked through some tips, some tricks, and some very important aspects of enhancing quality control with a benchtop spectrophotometer, selecting the right device with the right inter-instrument agreement for your tolerance needs, okay? You got to start there with the right tools. And then you need to tie your tolerance to your customer's true acceptance criteria. What's interesting is it's very common for a customer to say, yep, here's what we need you to produce, and my tolerance is this. And yet you will have the experience of giving them product that passes their numeric tolerance that they reject, and they'll reject it because they'll tell you, oh, that color's not good. So you need to, if you start to get that kind of feedback, if they said their tolerance is 1 and they're telling you all these samples you gave them that are at 0.95 are failed, they won't accept them, then you probably need to change your tolerance to 0.9 so that you're only passing things you know your customer will actually accept based on their feedback. So it's really important to keep those things tied together. And then make your tolerance work for you and help you avoid waste, right? Using warning levels, looking at your delta values to help you know okay, I'm getting a warning, I'm in the yellow, I need to do something or I'm going to start failing. What do my delta LAB or delta LCH values tell me that I need to change in order to get my color back on target? All right, with that, we're going to move on to Q&A, but before I dive into the Q&A, Robert's got a poll he wants to give us. Okay, so we have a question about what if your customer, supplier, the workflow you're in, I would interpret this as, has a spectro from another manufacturer? Well, yes, there are concerns there, of course, because their inter-instrument agreement of another manufacturer's instrument is going to be to their centroid, not to our centroid. There are some solutions to that. The number one thing, though, I would mention is, to start with, you've got to be sure that the instruments you're using are the same geometry. And what I mean by that is there are all of X-Rite's benchtop spectrophotometers are sphere based, or they're sometimes called D8 instruments. They're spherical illumination, so that means that they get a diffuse illumination. You need to make sure you don't have you're not trying to compare with somebody who's using a 045 instrument or a multi-angle instrument, because those instruments can measure color too, but they don't have the same geometry. Okay, so number one, make sure that that's true, that you're all using the same geometry of instruments. And then, there's some work that needs to be done. There's ways you can test, how does my instrument and their instrument correlate? A set of samples that you measure on yours and they measure on theirs, right? That get the same physical samples marked with the spot you're measuring, sent and measured by both, will help you understand, oh, yeah, okay, look, your instrument always reads darker than ours does, or redder, or whatever. You can help to at least quantify what that difference might be. And then the last thing is, there are some competitive instruments that we can net profile. Okay, meaning use the net profiler solution, and we would then be profiling that device to read like, correcting it to read like an X-Rite centroid device. So that's a possibility as well. Okay. Next question is, what is net profiler measuring on those profile charts? So it's literally a set of ceramic tiles. Okay. Those ceramic tiles are measured by an X-Rite centroid instrument at X-Rite and then sent to you. The tiles are serialized. When you run the software, it connects to this database out in the cloud that says, okay, I know what the centroid reflectance data for that tile is. Now you measure with your instrument, and now we're going to see what your instrument's reflectance data for that tile is. I'm going to compare your instrument to the centroid, and we do this across all the tiles. and then we apply algorithms and things to correct your instrument, and it literally adjusts the reflectance data that would be coming out of the instrument to the software. You know, we're basically applying a correction algorithm to those things. So it's based on ceramic tiles and known values from a centroid. Somebody asked about inter-instrument. We talked about inter-instrument agreement, did not mention repeatability. Yeah, repeatability on instruments is rated as well. The reason that we don't talk about it as much is because benchtop instruments tend to be extremely repeatable. They're all rated for that, just like they are. But if I talk about an instrument, for example, even though, you know, a CI 7600 that is a 0.15 delta E inter-instrument agreement, its repeatability is like 0.01 or less. So it's almost down to noise, if you will. So we don't talk about it. It's still as much because it's not the biggest variable that we have to be concerned about, but indeed it is a concern, okay? Somebody asked about measuring, some solution for measuring curved elements. Yes, you know, we do have some holders and things that will help you to present the curved element to the instrument in a consistent manner. The fact that it's curved means light is going to be lost, right? Because even if you put it up to the aperture, there's light sneaking out the sides if it's curved away from the instrument. So the key to that is to have it consistently aligned, so you always lose the same amount of light, if you want to think of it that way. You know, if the one holder I showed for the preformed plastic, right? That's a curved piece, and we have holders that could put that in the front for reflectance as well. And again, it's all about consistent presentation of the sample. So the fact that it's curved, as long as I present it the same way every time, addresses that. Yeah, we had a second question about curved surfaces, 45, whether to use 45-0 or D8 for that. It's probably, quite honestly, the 45-0 instrument is going to be more susceptible to variation in the sample presentation because you have a directional light source. If you have a curved sample up against a directional light source and you vary the presentation at all, that directionality now bounces off differently off the curvature, where a diffuse, a D8 sphere instrument, because it's a diffuse light and coming from all directions, those minor microscopic, if you will, variations in orientation aren't going to negatively impact you as much. So a D8 instrument is likely the best answer to that. Okay, I think we got time for maybe one more. By the way, if we don't get to your question, if you asked a question in the question panel and we don't get to it, we will respond to them. So respond to you via email. So last question, how can we manage with overseas partners that have the same machine, same settings, but vastly different readings? Yeah, number one question that X-Rite tech support has gotten for the, I've been with X-Rite for 30 years. It was the number one question the day I started. It's still the number one question we get today. I'm measuring the same thing as someone else and we're getting different answers. You know, how do we dig? Boy, how do you dig into that? It's a set of tests, right? Same machine, same setting, vastly different readings. Are we talking about measuring the exact same sample? Is the environment the same? That's often a big part of the difference, because even if the instruments are both measuring properly, okay, even if you're measuring the exact same sample, but if I'm measuring it at 72 degrees and it's 72 Fahrenheit where I sit, and you're measuring it and it's 85 degrees Fahrenheit where you sit, that 13-degree Fahrenheit difference, the color of the sample you're measuring will have changed. Every color on planet Earth is what's called thermochromatic, which means as the temperature changes, its color literally changes. And if you could look at the same sample at 2 different temperatures simultaneously, you would even see the color difference. So there's some of that that's going on. Yeah, there, you know, that's one of those things. If you're struggling with, you know, same machine, same settings, all these kinds of things, that's something we are. Our tech support team is really, really good at helping you ask lots of why questions or how questions to dig into finding ultimately what's the root cause of why these things are measuring differently or giving us different answers. Okay, so with that, as I said, if we didn't get to your question, we will answer it. We'd like to thank you all for your time today. As Robert mentioned, this has been recorded. You will be receiving a link to the recording, so you can refer back to it later. And thank you all so much. Wish you all very well and have a great rest of your day.
Thank you, everyone.